Welcome back, everyone. I hope you're ready to do some more questions. I really enjoy these questions, in case you hadn't noticed. They're lots of fun. So, here we go. We have a ball projected vertically upwards, in other words, thrown, with a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as zero reference. What does that mean? That means that we compare everything to the ground as my 0 point. So everything above the ground is either negative or positive in terms of displacement. Everything below the ground is negative or positive. Okay? Below the ground would be hard because it's the ground. They want us to calculate the time taken by the ball to return to the ground, and then they want us to sketch a time velocity graph. First decision we have to make, which direction do we want to take as positive? I always take original direction as positive. So here we go. My initial velocity is 16 meters per second. I'm going to come back to my final. My acceleration is minus 9,8 meters per second squared. And we want a time. Here we now have a choice, because we know the ball's going to go up, it's going to stop, and it's going to come back down and hit the ground. Here we need to be careful. You are very welcome to calculate the time it takes to get to the top and then times the time by 2. But I want to show you what makes vectors so special is the fact that if it leaves the ground at 16 meters per second, it's going to hit the ground at minus 16 meters per second. Okay? You can see that in graphs when you do them nice and accurately. And why? Because throughout the motion, it's experiencing the same acceleration. If the acceleration changed, this wouldn't be possible. So that means if I take the whole motion into account, I can do this in one step. If I make final velocity minus 16. Okay, because watch, if I now do, the easiest equation is going to be VF equal to VI plus A delta T. So I have minus 16, 16 minus 9,8. At this point, I need to calculate time. If I calculate time and I get a negative answer, I have made a mistake. Time is a scalar. As much as we would love time to go backwards, it can't. It doesn't have a direction. Time is just time. So that means when I do my calculations, I must get a positive time. So that's a check for you. If you get negative time, you've made a mistake with your signs. So to get this time on its own, I'm going to take the 16 over. So I'm going to get minus 32 minus 9,8 delta T. So now I'm going to have to go minus 32 divided by minus 9,8, which I can't do in my head. So minus 32 divided by minus 9.8. And I get 3,2. Remember, we round off to 2 decimal places, so that's going to be 3,27. 3,27 seconds. So I know it takes 3,27 seconds for it to get up and come back down. Nice and simple. We can do this. The next question says they want to sketch the velocity time graph. What I want us to do on this graph is I want us to put the values we know. So I want initial velocity, I want final velocity, and we're going to look at some times. Okay, so you get used to the way they can ask it. We have straight lines because you're going to use a ruler. time velocity. And now what we knew, let's close my bracket, is that it left at 16 meters per second. It hit the ground at minus 16 meters per second. So my graph does this. I also know that this time is 3,27. What I could have also asked you is what is the time it takes to get to the top of its motion? That's quite nice, because now I'm going to take 3,27 and divide by 2, because it's the same time up as down. So I'm not using the whole decimal, because I've now rounded it off. So 3.27 divided by 2, and I get 1,635. When I put the 1,635, I have to keep all three of those decimals now, because it's exactly halfway. I can't round it off, because then what we're saying is that it's just a little slower to get up than it is to get down, which isn't true. It's the same to go up, same to come down. So just be careful with that one. This, if I ask you a question like this, where it's not just draw the sketch of the shape, it starts to become worth a few more marks, because I want to see whether you can take the information you found and make sense out of it. Okay, so that's what that question is. Right. Okay, the two velocity time graphs are for the two objects A and B falling vertically. Both objects start from a height of 8, strike the ground at the same time. So here's our graphs. Which one of the graphs was projected? Which one was thrown? Now, if we look at it, it's got to be A. Why? Because it has an initial velocity. I don't care that this time is different. All that is telling me is that B was dropped, and a little while later, A was thrown. That's all. Okay? Now they say, calculate T. Okay, I want that time. Now, here life gets a little interesting for us, because we don't actually have, well, they start from a height of 8, okay? This isn't really so difficult. They both started from 8, which means, well, this is not a nice question actually. That area gives me a value of 8. And if I take the area under this graph here, that's also going to give me 8. And I'm going to have all sorts of things. I probably should have given you a little bit more information. But what I need you to see, and I'm actually not going to finish this question, I'm going to leave it for you to sort, is that the area of the first object is equal to the area of B. Okay? Here, I really should have given you more information, because I didn't. Finding these areas is actually going to be quite difficult. I needed to give you something else to help you. What I do know is that B hits the ground with the same velocity as A. So this question, as it's given to you, becomes like a level 4 question. It's actually quite difficult. Simultaneous equations. But what I needed you to see here is that the areas are the same. So even though I've got a couple of unknowns, all right, I can still create two equations. And by doing that, I can get rid of two of my unknowns, okay? So then they wanted V. I can't find V until I know time, because once I know this time, it's going to be part of the simultaneous equations we did to get time. Once I know time, I can work out velocity, because I know the area of B. Okay, so the velocity would be the height. Might have been a little difficult to put in here, sorry. Okay, how does the area And that's what we've just done. The areas are the same. Why? Because they fell the same distance. Their displacement is equal, so their area is equal. Okay? They want the magnitude and direction of the vector represented by the gradient. Well, it's 9.8 meters per second squared. Down. It's acceleration. Sure. I did do a difficult question there, but sometimes you've got to see them because they're important, okay? Hopefully, graphs are a little easier now. Hopefully, sometimes you've got to go back and think about it, but that's where we're going to end it for today, so I will see you next time.